Sauce here. This is a video lesson for pre-algebra, types of triangles. I've drawn two triangles here. One has a right angle symbol in it. This right angle has a measure of 90 degrees. And because this triangle has a right angle in it, we can call it a right triangle. Any triangle that has one right angle in it is a right triangle. A triangle can't have more than one right angle. I've drawn another triangle here, but I haven't named it yet. It doesn't have a right angle. It has three angles that we could say are acute angles because their measures are small, between 0 and 90 degrees. If a triangle has all three angles acute angles, then we can call it an acute triangle. These are two different kinds of triangles. We have two different names for them. Their names describe something that's true about that triangle. We'll put in parentheses what's true about an acute triangle is it has three acute angles. And what can be said about a right triangle is it has one right angle in it. I'm going to draw a third triangle in this group, and I'm going to begin with a large angle, or an obtuse angle, an angle whose measure is between 90 and 180 degrees. If I start with that angle and make a triangle out of it, the other two angles are not going to be obtuse angles. This triangle only has one obtuse angle, but that's enough to call this an obtuse triangle. It's not possible to have more than one obtuse angle in a triangle, and we'll make a note that an obtuse triangle has one obtuse angle. There's construction going on that might be picked up by the mic. These three triangles here get their name from the type of angles that are in the triangle. So we could say these triangles are classified by angle. We're going to make another group of triangles, and these will be classified by their sides. Observing the side measure will determine what kind of triangle it is. For example, a triangle has three sides, but I can use notation, in this case one tick mark and two tick marks on another side to show that those two sides are not equal in measure. They have different side lengths. And if I use three tick marks here, then that third side has a different measure than the other two. I don't know what the measures are. It could be anything, but what I do know by this notation is that all three sides have different lengths. This type of triangle is called a scalene. And what we know about scalene triangles is that have no sides equal to each other. Well, we can draw a triangle that does have two of its sides equal in measure. I can use notation, one tick mark and one tick mark to show we may not know the lengths of those sides, but we do know that those two sides are equal to each other. And this third side has two tick marks. So this side is not equal to the other two. This type of triangle is called isosceles. And its feature is that there are two sides that are equal. Triangles have three sides, of course. If all three sides are equal, we could put a tick mark, one tick mark, to say they're all equal to each other. We may not know their measure, but we know that they're all equal. This is called an equilateral. An equilateral has all sides being equal. Now, it's also true that the angles of an equilateral triangle are all equal as well, but we're classifying this equilateral triangle by what we know about the equal sides. So we've got a group of triangles and their names based on side information. Now, it is possible to combine several of these. We could have a triangle that has a right angle in it, but also has two side measures being equal. So if we have both of those qualities going on in the same triangle, we can draw an example of that. A right angle with two sides being equal is both a right triangle and an isosceles triangle. We can call it a right isosceles. We can make another combination. We could have an obtuse triangle that also has two equal sides. We can make a version of that. One obtuse angle, two sides being equal, and this would be an obtuse isosceles. One more example, a right triangle, triangle with a right angle, but no sides being equal, could be called a right scalene. We could also have obtuse scalene. We cannot have an equilateral triangle that is a right triangle as well. That's an impossible combination. So we have triangles and their names classified by angle, classified by side, and some of these combinations can be brought together.